This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe think tank.
The Fringe think tank it is then. Now let's give them back their destiny and open it up to the world.
Hello, everyone. My name is Nathan, otherwise known as Old Man Builds, and we have Benny Factor here with me. How you doing, Ben?
I'm good. How you doing, Nathan?
Oh, I'm doing good, man. Everything's starting to come around and do good.
Well, that's awesome. That's awesome. So, what do we got lined up for today?
Well, I kind of have some stuff on my my one wire energy. I kind of built a like a little energy well, and whatever I put in it, it lights up.
Nice. Well, I'm excited to check that out. On my end, we did order some MOSFETs. So we got an IRF 540 MOSFET that Daniel Nunez utilized in some capacity. So I'm at some point in the background, I might head over to the mini lab and test that a little bit. If we have anything interesting, obviously I'll set up the camera.
Right on. Well, I don't know what Crypto's doing with his thumb down, but what's going on? You like my tinfoil Tesla coil? Yeah, that's pretty cool, huh? So, you know what?
Didn't see that one. Tinfoil Tesla coil.
You didn't see that one yet?
No, you got to show me this.
Okay, so like I told you, I built a little energy well. So everything I put in it lights up. So like true Fringe think style, excuse me, my speech is off. True Fringe think tank style. I'm just going to show it. So I'm going to bring it up here for you.
Yeah, let's see it. I assume it's something that you recently uploaded on your channel. I haven't been on YouTube like for the last day or two.
Oh yeah, I did that, and then I'm going to show everybody kind of some behind the scenes stuff. So, yeah, so here it is. You can see the secondary is just tinfoil.
Yeah.
Now I'll show you later on. I'll pull the cover back, and you'll just see the pipe underneath.
But just there's no winding. It's just tinfoil.
Just tinfoil.
WTF, Nathan? WTF? Like, like what are you gonna build these Tesla coils out of next? Like,
well, you never know, man.
I got an apple, a pencil, and this screwdriver. I'm gonna build a Tesla coil.
Hey, don't put it past me. I might do it. I just used my pencil as a wire a little while back. Absolutely hilarious. I did it with the one wire energy, and I should do it with the hot energy too to show the difference. But I think it might explode or start cracking when I put the hot energy into it.
Oh wow. Yeah, you're like MacGyver over here.
Yeah. Well, I told you I built a little energy well. So here, I'll just play this a little bit so people can see it.
Yeah, let's check it out.
Wanted to build a Tesla coil. I wanted to do something completely different than everyone else. So instead of putting copper wire and winding it up the pipe, I simply put aluminum foil on it. Let's take a look. Yep. You look down it. Nothing really in there. Just a 4-inch pipe with aluminum foil on it. I got a copper #1 winding, 1/4 inch, hollow. Got it connected up. Well, now you see what it is. Go ahead and put this thing on the stand here. And let's turn it on. Woohoo, baby. Look at that. Tesla coil out of aluminum foil. Who'd have ever thought?
Wow.
There's no breakout.
Turn it
at
into
the
a
top.
hat.
You see it's clearly resonating.
Yeah, that's crazy.
Interesting, huh?
That's funny, isn't it?
Yeah.
You never see it.
Goes for distance too. Let's check it out. I'll turn off the light. We'll see how far of a distance I can push this thing.
What's funny is somebody asked me why this is so special. I go, well, how many tinfoil Tesla coils have you ever seen?
Yeah. Yes, son of a bee.
Oh, come on now. You got to be nice about it. Look how far that is.
Man, that's pretty good. I mean, you could just see it. We're a little over 2 feet out, and we still got this light going. And now it's going
Hey,
out.
Mike.
Now it's going on.
What's up, Mike?
Right about there's our distance.
How you doing,
For
Joe?
those of you who watch my channel before, you know what I'm doing. Or at least you have a good idea. But for those of you who haven't, well, welcome to my world. Build things out of Tesla coils that most people don't ever think of.
I just keep thinking you could
So
dub the
interesting.
Darth Vader breathing on top of this video clip
Wonder
right
if I
here.
can get any breakout out of the top. Take something metal.
Use the force.
Oh, man. You know, sometimes when I do my videos, Ben, you hear the breath at the beginning. I almost sound like a fat Darth Vader doing it.
You should put Darth Vader's breathing on top of it just to cover it up a little bit and be funny. Because you're waving around a big giant fluorescent tube. Looks like a lightsaber.
When I get like one of those 6-foot black lights and start swinging it around. Like,
Yeah.
Impressive. Most impressive.
maybe find a red light and do it. That'd be cool. Oh, man. Okay, this is pretty cool, right? All right, so I'll stop sharing that. I'm going to bring up something else, guys. And this is kind of like something I did for the members on my channel. And I wanted to show it to you guys.
Ooh, members only content.
Well, it's true Fringe think tank style, man. I can tell you that.
Oh, yeah. Oh, you heard it, guys. You're going to get a glimpse at some members only content right here. Awesome.
So, real quick before I do that, I just want to tell everybody just what it is. Membership on there, you get the emojis. You're able to put them in the chat and have fun with them. So just so you know that. And then I always put content in there that normally you don't see, and some of it's just absolutely hilarious. Okay, with that said, the title of this thing is Everything Goes in the Hole.
I have my one wire energy. At this point, you know how I hook it up. Here's the cool thing. Now, the only thing I've connected here is the one wire, obviously, and we're just going to stuff stuff in the hole, and we're going to see what lights up. So what do we have here? We have a jar here. We have quartz in there. We have some salt in there. Just like everything left over from other experiments. And then just some tin foil around it. We're going to stuff that in the hole. Then I'm going to take these tin cans here and stuff them in the hole. I'll take this rod and put it in the hole. I'll take the bigger rod and put it in the hole. And then this right here, tin foil. And look, it's only tin foil. It's gonna drive people nuts. There is no secondary on this. Just tin foil. That's it.
Yeah, you heard that, you son
That's
of a
going in
bee.
the
There's
hole
no
for sure.
secondary.
Now, let's begin our fun time of
Like, this is
stuffing
a
things in the
cornhole.
hole. Right, turn it on. We got power, and all we're gonna do is check it with the light and make sure we get it to run.
And what is this? Just water?
Oh, dude, it's everything in there.
Oh, and in
Yep,
that
sure does
fluid
light
that's
up.
like, oh wow.
Nice. Yeah, people say, "Oh, it's a Leyden jar and do it with static electricity." Well, I can do it with one wire energy. Look at that, right in the hole. Let's just see what it does when I put it down in there. Ooh,
Hey, that's a
baby.
real glass hole.
Like that rod in the hole.
Hey, don't be a glass hole now.
Turn this thing off. Some of the stuff is metal, and I don't
Oh.
want to get shocked. The glass was okay. All right,
I'll stop.
we have a can here, and well, simply going to take the wire and I'm going to attach
Hey,
it
Mike.
to it, because if I put it over there, you'll never know which one's going to go on. So we're on now. You see it lights up, but that could just be something else. There we go. Right there. Can in the hole. Lights up nice and bright. Ooh, it's sparking a little bit on there too. Ooh.
He's dangling his bits on the top.
Like spark. Ah, big enough. All right. Can in the hole, done. Good to go. That can lights up. Lights the hole.
Apparently, I can't
All right.
stop. I'm sorry.
Yeah. I'm sure it'll get zapped. I might get zapped anyway. No.
Oh,
All right. We got a small rod in the hole. Bring what you got, I guess, huh? Turn it on.
This is impressive, but also hilarious.
Yep, that lights up. Maybe small, but you're getting the job done. All right, small rod in the hole. Check. Still works. She still likes it. All right. Now, here we go.
His name is Nettis Rodman.
Again, this one, we just put a sleeve on it. That's it. No whining. Put it right there. And it still lights up. Yep. Took it all. All right. Now, so we got aluminum in there. That seems to be good. Works. This thing here is steel. Yeah, little mud thing. You just kind of mix it up with the mud. And shove it in the hole.
Ooh. The mud hole?
All right.
barely fit.
Turn it back on. Let's see if we light up again. Oh yeah, baby.
Yeah.
It's all
he's-
different kinds.
Oh my god.
That lights up
it's just
good.
The tip.
All right, well. Let's just add a can to the top. Hold on, let me turn it off.
Whole glass.
I hope there's no soda in these. That would suck.
You ever shake up a
There we
can of
go,
soda
Dr.
and hand
Pepper,
it to your
upside
friend?
down.
I have, because that's a no. Somebody's done that to me.
Turn this sucker back on. And there we go. Dr. Pepper likes it.
It just, I told you it's an energy well. It just
And
works.
let's just one wire energy is wild, guys. It's just so funny.
All right, let's try one more thing. If it likes all this big stuff, let's see if it likes some small stuff. You saw that it liked the small rod, but maybe, that was still too big. So take that big one out.
There's
All right, so now all we're going to do is turn it on. We're just going to take this tip here. Let's see if it'll light up just based on that little clip.
just the tip.
Yeah, just the tip. Little guy too.
Wow.
Ooh, like the outside.
That's
Ooh.
a tiny alligator clip.
Let's see, it's down there. It's waving.
Was that like
Lit
28
up.
gauge?
Let's see if it do it again.
Just wiggle it a little bit, Ben.
Yeah, it'll even like that little guy.
One
That's
size
so cool.
fits all.
It's all.
Still lights up.
The hole is never too
So-
big.
Ooh, I know what I didn't do. Let's just have a little more fun.
Just a little guy.
Say, well, okay, if it lights up with that, we'll just drop this in there.
Oh no. Oh man.
Yeah,
he
still
did.
lights up. All right, we're gonna throw this other one in there.
Having fun today.
Yeah, just stuffing everything in the hole.
Yep, still lights up. Still likes it. Let's see.
I'll put the hole in the little hole.
Ooh, it really likes it now. Look at that. Yeah, it gets lit up bright. It's very interesting the way this is working. I'm sure it's sparking everywhere. Let's find out. Get our inner pyro going. Yeah, a tiny spark. Nothing to write home about.
Oh,
Anyway, it's just funny, guys. This one wire energy works different than anything else you could think of. I mean, we just put a bunch of ridiculous stuff in the hole, and it likes it. What do you want me to say? It always works. So as long as it's some kind of metal, it's going to work probably. So anyway, that's kind of the behind the scenes on what's going on and, future experiments, stuff like that. It's really cool. Thanks, guys.
Well, Nathan, don't be surprised if people in the near future compliment you on your magnificent hole. Hear that, everybody? You got to send them an email. Show all the love for Nathan's hole.
they're taking screenshots of my hole.
Oh man. I tell you what.
Oh. All right, man. You guys want to see another one? Let's have a little fun today.
Yeah, load it up.
Okay. All right. Here we go. So somebody asked me for a pancake coil. So why not?
I had someone ask.
You put a big sausage on top of it.
Second
Fat one.
can. And let's
You
just
got
take a
pretty
look
big
at this.
sausages for that pancake over there, buddy.
So
Jack Link's
it's just
point.
PVC and it's literally tinfoil. There's no winding or nothing on it, nothing on the inside. Set it right there. Turn it on. Yep. Seems to work just fine.
Oh, it really likes the pancake coil too. Look at that.
Yeah, it does. It gets really bright at the
But
bottom.
it'll still work on that. It transfers just fine. Told you this energy's different.
It's
So,
just
well,
one
while
wire
we're playing
from the
with
pancake.
it, just try something else.
You're the whole.
Turn that off.
Is that just one wire that you have connected?
That's only one wire.
Wow. That's crazy. You're crazy, Nathan. I can't keep
Put
up
that
with
in
you.
there.
It's too much. Every day is something new.
Well, hold on. Look. Let's just. I light up sand and water in my front yard. I light up everything. Like there's hardly anything I come across that doesn't light up. I even took a full roll of what was it, 28 gauge wire and threw it down the center of this thing, man, and it just lit up. So, and I was
Wow.
creating sparks out of it. So this energy's
Wow.
different, man. I took a DC flyback and ran it based on this one wire. So, yeah, we'll keep playing it, man. Oh, I'm sorry. In the last test, someone was asking what was in the water. So that was just like a leftover from all the experiments. So I had quartz in there. I had salt in there and had water in there. So pretty much
Little
just
whiskey.
yeah, probably a little bit of sand, some dirt. I mean, who knows? It was
Yeah,
just a mix up.
It looked like a just like a dark, like muddy type of water.
Yeah, no, I did not pull it out of the toilet. I swear. Hand up. I swear I did not do that. Oh, man. All right.
Yeah, there it is. But that could have just been the pancake coil. Well, whatever it is, it's at a distance. I can tell you that.
So this part, you know, I got energy transfer once I stick it in there.
Put the rod in the hole.
That's right.
Oh, no.
Wow.
Got some energy transfer there. Look at that. We just put it underwater.
That's slightly inappropriate,
Underwater.
Nathan. I'm kidding.
It's just wiggling it.
Shake a couple times. You're good to go.
Shame.
Now,
what are you teaching people here?
let's see. Let's just find out what the pancake coil
No,
does.
that's
So
funny.
We'll just take that. Move that aside.
Oh,
Yeah, I guess whatever you put on there is going to resonate, I guess. I think it's
I
pretty
really need to build one
strong.
of those pancake coils.
So, but we know when we put the thing in the water, we got more energy. So, I don't know. You figure it out. Let me know. Just put stuff around it. Put some cans on here. See what they do. Oh, yeah. Just transfers the energy. Really what it's doing. To whatever it touches. Pretty interesting.
Oh, nice
Oh,
cans.
A couple more things. So
yeah, it's a good pair of cans, huh?
check this out. Okay, we got this here.
Oh,
We
man.
got that there. We'll throw that in there.
You got two waters now.
Yeah, it's,
Throw this in here.
You're trying to use it as
That'll
like
give us a couple extensions on it. Okay.
yeah, it doesn't matter what I hook this thing to, man. It's the only thing I have to worry about is feedback.
Right.
Because it'll turn the energy hot if it feeds back too much. If you got too much capacitance on one end.
So will it start boiling one of the waters?
I don't know if it boils water, but it definitely doesn't feel good to touch.
It's
Maybe.
lit up through all of that.
Yeah, it's still,
All right. Well, let's keep going. We might as well try something else. I got a plate here. Got an aluminum plate right here. Throw that back in the water. Yeah. It likes the plate. It's transferring energy just fine. I mean, look, I've already broken the energy. It literally is going in there into a jar, which is ridiculous in itself. Then I got a wire going over to another jar, and then that's ridiculous. And then let's just cook it to a plate. Well, okay. What's next? Well,
we could
Why don't
try
we
the
get an iron
gopher,
plate?
see how conductive the
why not
gopher is.
that? Let's just get an iron plate.
The wrong kind of conductive there, Ben. I don't think the gopher would appreciate that.
Oh wow!
So can we
What
stay
what is
conductive
this
to
thing that you
iron
busted
plate?
out?
Well, I don't know.
So I got a steel plate
Find
there. I
out.
think it's
Let's see
about
how
an
we
eighth
wanna
of an
do
inch
this.
or a
Let's
little bit
arrange
less.
it a little bit differently here. Sorry, I'm getting the shot.
Oh, you're gonna attach it like as capacitance. Yeah, I saw the
Yeah, I
spark.
think it's all connected.
Mm.
It needs to be grounded in some way. Look at my hand. I touched the wire.
Got me there. Something was going
It
on.
turned hot because of too much capacitance going back.
Oh wow!
Energy did a little feedback on me. Whew.
Oh, you didn't touch the green one. You touched. Is it the green one that you touched?
So, okay, there's more capacitance attached to it.
Mhm.
So it now feeds back into my coil. So
Oh, I see what you're saying. Okay.
so it goes back and it basically sours the well. So you would have to change it up, but I mean that's a lot of mass there in that iron plate. So you'll notice that it changed the energy. So when I touch it, it lights up. You know what I mean? And it's usually out. So it needed a lot more. So if I would have grounded it, it would have pulled the energy through. But because I didn't, it fed back to my coil. And I don't have my rodent coil hooked in here to stop it. So, because someone was asking, can I do it without the rodent coil? And the answer is absolutely yes. And
Yeah.
you see it resonating the whole time. You see when it goes out of resonance. Like right now, it's out. I can tell you by looking at the screen, and I'll have to turn it off and turn it back on. So, and do I still use the same capacitors? Yeah, all my primary setup is exactly the same.
You know, something tells me this thing's going to need some grounding. You can see it turns on. Interesting. Yeah, why don't we just start hooking more wires in?
Hi, Lulu.
Why not?
Hey, Lulu.
There we go. I don't know that it makes a loop or anything. I don't know. Whatever. Just some cool stuff. Look at that. That's ridiculous. Wow. You just pretty much do whatever you want, huh? I guess as long as you know what you're doing.
So, yeah, I'll stop sharing that one. Just somebody asked, so I just want to show my primary setup, and then hopefully Ben will figure out what you got going on for the day because it sounds like you got cool stuff. So,
Yeah. Yeah, we might go to the lab and do a little testing. I don't know.
right on. Okay, give me 1 second. Let me pull this
I
up.
tried to hook up the MOSFET to the Lightning Thief with the 12-volt battery as a source, but it didn't do anything, and I think that's because it needs a little bit more power.
Oh, okay.
Yeah, then maybe the 12-volt can supply, so I'm going to hook it up to the power supply.
Nice.
Okay, so this right here, I have a video on this, guys. I just wanted to show you. So I go over exactly what's in my Tesla coil to do it, and I'll even take off the capacitors for you and put on the other ones. I'll show you the capacitors on there. I'll go ahead and give you guys a link in the chat for this, but it's real simple. It's a $30 ZVS from Amazon. It's 2 capacitors from Amazon. You can buy them somewhere else. They'll probably be cheaper, but yeah, I'll just leave the link for you guys, and I'll tell you exactly which side hooks in where. And there's a second video that goes to this that's a part 2, and it'll show you how to hook it into your Tesla coil. But it's all fairly simple. Pull out too easy. So let's see if I can't pull the number off of this. Right there. Those are the capacitors that I use. They're $20 each on Amazon. The board that I get's about $35. So, you know, $35 plus another $40 for the 2 caps. Now, you can get these caps cheaper somewhere else. I just bought it on Amazon. It's easy to find. So, what's going on, Mike?
No, not too much. How are you guys doing?
Huh?
Hey, I have an idea for a New Year's Eve show. We'll call it
Okay.
year,
Hey, Mike.
year of the Hole.
Yeah, well, I'll be honest with you, man. When I can get this Tesla coil beefed up, man, I can make one massive well in there. It's like an ether well. I
Try
can put in anything.
try energizing plastics. Polyethylene is really will hold a charge. It's basically like an electret.
Okay.
Have any
Well,
polyethylene around? Charge
I
it up
have-
and then
Hold on. I have the PLA with the metal in it, metal shavings. I have that
that'll
one.
work. That'll work. Yep. But
That'll
just
trip people out.
plastic. Just plastic. Because Bandini, when he was doing some of his tests, he was able to light up a neon bulb right off the plastic container of the battery
Mm.
in the terminal.
I have plastic in there, and it's PLA, but PLA doesn't take a charge like that. So
No, try polyethylene.
okay,
That's a good, try that one.
got it. I'll have to try that. Okay, that's just like an injected plastic, right?
Yeah, they use it like in cups and stuff like that, you know, the
Okay.
throwaway cups, stuff like that. Apparently, it holds a really good static charge. So if you could charge up like a cup, plastic cup, put the light near it, you might be able to light up the light.
I'll definitely give that a try. Yeah, so
How about styrofoam? Have you tried styrofoam?
tried the packing material, didn't work. Styrofoam, not so much. If I light up my table, so if I take my DC flyback and I do a double DC flyback, so put them in series, right?
Yeah.
I can statically charge my table.
Yeah.
Because it's melamine. So
Mm.
I could get it charged, and then I could do some funny stuff on there with some styrofoam. But
Yeah.
it kind of just, it's bad for my garage and all my electronics to start playing with that thing.
Yeah. You can start blowing your meters and stuff.
Oh yeah, I fried a whole table full of stuff one day. It was not fun.
Well, that
So-
happened with my partner and his. We're working on the power cell. He had 2 brand new meters in the box, hasn't been opened, and last week he opened them up and tried to use them, and all 3 of them are fried.
Oh, yeah.
So we don't know exactly what caused that to happen. I said either you had really bad luck and got 3 bad meters, or because of the battery stuff that we've been working on, some reaction happened and fried the electronics on the. And he said the batteries were dead too. So he put fresh batteries in, and he said the batteries, even with new ones, they still wouldn't work.
Hmm.
So
No, I've had them fry on me, and they put out junk readings, and right away they're done. You
Yeah.
did something to the software, and you probably reset them, but for $40, I don't think I'm gonna bring it down somewhere for that.
Yeah.
So, yeah, what I was telling everybody is it's kind of like a little energy well.
Yeah.
So Gerald always says he's got an ether in the center of his coil. I think I found the same thing, but it's like a single hat trick compared to his. So I get one frequency, and on general, it's 426 kilohertz is what I'm running. And then depending on what you put on the load and everything, it'll drop a little bit. But
that's pretty high frequency you're playing with.
yeah, it's definitely RF through the whole thing. And the cool thing is, I didn't hook in my magnetics on this one, but when I do, and I put a little bit of heat on the outside, man, does this thing love that?
Yeah.
So
it tracks it. Yeah. I meant to ask you what's happened with Gerald. I haven't seen him on.
Yeah, I just got an email back from him today. He said he'd be here Wednesday.
Okay.
Yeah, I think he went through a cold and wasn't feeling well, and he got backed up on everything he was doing. And
yeah,
what I mean? He may have something else going on, but that's as much as I know so far. And that's what he said.
Yeah. I think he runs a catering business or something like that, or
Yeah,
whatever.
I think so too. So, yeah, he'll be back. So I was kind of hoping he'd be here tonight, but he said Wednesday. So,
yeah, that's good.
Yeah, but I'm kind of excited, man. This energy is doing a lot, and it's really changing. And I took your idea, by the way, from Friday about the aluminum foil.
Yeah.
Because you did it with the static. I go, well, okay, now I got to do it with my energy and find out.
Yeah, and it works. Yeah, because it's a heavy side component. As soon as you create that energy well, like you're saying, any electrons that are present in that space around that is now going to get attached. And it's like the skin effect, right?
Mm-hmm.
So it's going to stay on the surface of whatever is conductive in its proximity, right? It's automatically going to attach itself, and you can feel that static charge, on the hair on your arms, right? When you get that static feeling, it's the same
not a lot
thing.
of static in it. Yeah, it's the same kind of feeling. Don't get me wrong, but there's no static in it. It's like none of my hair stands up. None of the table gets charged up like that. It's a little bit different than everything, but it's a lot of energy.
Yeah. Yeah, it's a weird phenomenon.
Yeah, so if I did what Tesla did and I brought the diameter of the pipe out, so say, for instance, I brought it out to 10 or 12 inches,
right,
and then I added more energy to it, man, would I have a good gravity well.
Yeah,
then
you gain a lot of power. A lot of people don't realize you gain a lot of power in the magnetic field on the diameter of the coil, not the length.
Yeah.
So the bigger the diameter, the bigger the field. As simple as that.
Yeah. So it has a heat on the outside. It has a cooling factor on the inside. That'll only get bigger with more power. It's just going to amplify it. So the problem is I don't have the correct geometry in the round coils in order to transfer that energy where I want it. So Gerald has the ability to go north and south and flip it. He also has the ability to transfer the heat where he wants it, inside, outside. So I'm not able to do that with this yet, but that's kind of one of the next progressions in the steps of it.
Yep. Well, what he's done is pretty complex. To replicate his coils will take quite some time to do. It's
beyond complex.
Yeah, it's too intricate for the average person to do it. And he said when he was building it, he screwed it up a few times. He had to go wind it back and then wind it again to get it right.
183 coils is what he built.
Yeah.
So, yeah. But we're actually, the good thing is it's low enough voltage we can map it out, right? 40 volts, not too bad. Easy driver, always works for me. I don't blow it out unless I go over that amount, or if I don't correctly see the amount of material I'm connecting to it, then it'll go to a bad resonance right away and then it'll fry. But as long as I keep those components in check, that board works perfect.
Yeah. Actually, I got that plasma ball or plasma tower. I could show you it.
Oh, absolutely. You want to run that?
Like, I don't actually have the circuit done, but I can show you the actual.
Well, you can
Plasma.
send the video. Just present the video that you showed.
Yeah, here, just let me switch my camera. So, oops. So it's really nice.
Oh, that is nice. Look at that.
Yeah, and it puts off a lot of charge. So, like the tube I got here, I could just set it right beside it, and if I hook up a wire to it now, it's going to carry power through it. So it can be anywhere around it. So if I wanted to, I could put 5 or 8 of these things around it, have a separate wire connection with a bridge rectifier off of each one of these, and have 5 times the amount of power coming out.
Nice.
Right? So
Yeah.
I know I can get 9 watts out of one of them. So if I add 5 more, 5 times 9,
Hey.
45.
I was going to ask you, Mike, you told me last time that reversing the coil on one of these things would actually give you more amps. So
Yeah.
could I literally put like duct tape over one part of it and then run some foil the opposite way?
Or a wire itself the opposite way, yes. Yep.
Okay.
Yep. You could do multi-layer. Yep. Do one full layer in clockwise, and then foil tape it, insulated tape, something like plastic tape or even duct tape maybe. And after you do that, then wind the second winding counterclockwise right over top of the original. So you'll.
Okay, real quick, just so everybody's filled in on the conversation we had, we were looking at Don Smith's stuff and talking about it on Friday. And Mike was saying run one wire clockwise to get the volts, run one wire the counterclockwise in order to get the amps. We'll put them into a Y configuration. We'll spark gap the volts so that we don't get any pushback on it. It would be like a diode to it, but we can combine our volts and amps that way.
Yep. Or you could use a high voltage diode. I've seen some guys do that. That works well too. But the spark gap, actually, that was in one of Don Smith's schematics that he had. He used an actual spark gap there. Or he actually, instead of doing it at the center tap, he would do a one-way diode, high voltage diode off the center tap, and he would put the spark gap just before it goes to ground.
Okay.
So
there's a lot of good stuff in there, man. I really want to build Don Smith's device. It's going to take a little bit.
Well, you're more an advanced builder, so your chances are you're probably going to be successful building it. But for a newbie or whatever, it's going to be extremely difficult. It's more for the advanced builder for sure, and also the safety stuff too, right?
Yeah. Well, I think the biggest key is I'm just going to look for radio frequency in all the coils. So I'll set them up and just do the math on it. And as long as I'm on my primary, I hit like say 50, and then on the secondary one, I'll try to hit 100. So I'll just double it, and then just make sure that the RF works that way. And it's just a 20K ohm resistor on there on my frequency device, and we'll just check it out and make sure they're the same frequency device. Sorry. Mine's kind of shot right now. I've been doing tests all day. So,
Yeah, sometimes you got to take a little break from it.
yeah. But I think as long as we map it out, it'd be okay. Just check, you know what I mean, everything on it and see what it is, and then I think we'll be all right. It should work pretty close to perfect by the time I'm done.
Yeah. Yeah, you built quite a few devices. There's several of them. Let's see. 1, 2, 3, 4. The one he had that was kind of controversial is the one he had in the black suitcase, the Tesla Tech in 1994, and he was running, I believe, 1,000 watts of lights, incandescent bulbs with it, and it was a toroid transformer about yay big, and it was made with that what do you call met glass. It was formed out of met glass, and he built the coil out of that, and had one of those little high voltage modules. The one that I had, I think it was 20 kVA, I think, in it, and he was actually able to light up 1,000 watts worth of light bulbs.
That's cool. So, do you think one of those little taser modules would do it?
Yeah, I'm just worried about the heating issue if you have it on too long.
Oh, okay. So probably one of the better ones will do it then.
Yeah, I have a negative ion transformer that works pretty good. It's 11 kVA. So I've been using that for a while. And they're pretty bulletproof. It takes quite a bit to actually fry those things, which I like. So there's a little bit of room for air, right?
Yeah, no kidding, huh? I hate when you turn something on and fry it before you're even able to figure out what's going on.
Yeah. Yeah, exactly.
Yeah, by the way, Joe Legacy was building the Don Smith thing and doing tests on it. So I think it would be perfect to kind of get mine done, and then we'll see if he wants to talk about it. We'll just kind of go back and forth.
Yeah.
I think all three of us in the room would be awesome.
Well, the way Joel was doing his, he was wrapping the foil around the fluorescent tube, and then you could just tap right off the fluorescent tube. So the plasma from the tube was energizing the tinfoil, and then all you have to do is tap right off the tinfoil that's wrapped around the tube, and there you go. You just tap one wire off it, right? And he shows you the diode setup, so you can tap off it like 50 times if you want, and have 50 channels of the same amount of power coming out.
Yeah.
So there's your over. That's over Unity right there.
Convert back transverse EM to run motors. Yes, once you convert it back to regular energy, and Mike had talked about this several times, you put it through your capacitors, and then you run a full bridge rectifier on it twice?
On both sides, yeah. Before the capacitor and after the capacitor.
Okay. And then you can get to regular energy with no problem.
Yeah, you could do at that point it is smoothened out and totally rectified completely. So now whatever's in those caps, you could use it as a DC potential, or you can modulate it and make AC with it. At that point you could do anything you want with it. So and you can loop it back to the source, and it will not know that it was the same power going in, because it's now back. You've changed the symmetry of it.
Yeah, you basically open the circuit, right?
Yeah, it's an open circuit.
Yeah. So do you have to put a draw on it, like a light or something like that?
I always have like some form of ballast, like if it's on the high voltage end, put a neon bulb on there. That's takes 90 volts right there to light it up. Or if you're doing it on the DC end, either have a motor hooked up to it or have a DC 12 volt light hooked up to it. Always have a ballast.
Okay. Yeah, always have something to pull the energy through, right?
Pull it through, but also, that you don't overcharge your capacitors and then you have a catastrophic failure.
Oh, yeah. That'd be bad. Those things like tend to hiss out and jump all over the place. Yeah, they're.
Oh, the big ones. I don't even want to be in the same room if one of those go off.
I haven't had one fully explode on me yet, but yeah.
I've had a decent sized one go off on me once, and it's like a firecracker going off in your bedroom.
Wow.
Pretty violent. But
Jeez.
so many things.
So right here, I was just on this gentleman's site. By Night 64, he was doing some experiments just like mine, and he had a Tesla coil out there, a rodent coil. He's almost got it set up. They're hitting it just right. I think my concern on his thing was more, I don't think his MOSFET's going to handle the power he needs to put into it because he's constantly checking the heat on it. So
yeah, that's a big problem. That's a big problem using the ZVS transformers, and that if you don't have the proper MOSFET hooked up to it, you'll get like heating up real fast. If you don't have it properly vented or heat sinked on it, you're going to toast it for sure.
I'll tell you right now, I got a Tesla coil one on my site that is a PNP, and absolutely beautiful, would change your life on this thing. And 40 volts all day long without an issue. And One Wire Energy absolutely loves this circuit, by the way. It is the best circuit ever for that.
It's Slayer circuit, right?
Is it for Slayer Snyder? Yeah. It really is. If you get a chance to check it out, man, check it out.
It's one of the better circuits out there.
Yeah. And it's just two components, really. Well, maybe three or four, I guess. It's simply a PNP transistor, and it's a 47K ohm resistor, and then you got a heat sink and a fan that goes to it.
Yeah.
That's it.
Yep.
No, not overcomplicated.
Yeah.
So,
but it does the trick.
Yeah. Well, that's the whole thing, isn't it? So you could put capacitors in the beginning of it if you wanted to, and not a problem. Just put some capacitors there and then run your ground line if you wanted to do that. I usually run it ungrounded, but you can ground it. Just put it in the ground line to your negative to the capacitor before it goes into the rest of the circuit, and you'll be fine. You can always double diode over the oh man, I want to say it's the emitter to the
I thought it was the gate to the emitter.
There you go. Double diode it so it doesn't get back pressure on it.
Yeah, because the gate is very sensitive. As soon as you fry the gate, that's it. You're finished.
Yeah, you're right. That's the one it is. So there is some protection work you could do to it, but I like to show people how simple it is.
Yeah, I think the gates on most MOSFETs are between 2 to 5 volts. Some maybe even lower. So yeah, it's a sensitive part of that circuit is the gate. You got to be very careful with it. They're prone to frying.
Yeah, I think we all find that out right away.
Oh yeah, I've done a few.
I get that Z44 on the MOSFET, and I fry that thing immediately. I think I fry it with just my soldering iron if I forget not to turn it down.
Yeah, the heat on it, could do thermal damage on the inside. Yep.
Oh, hold on, Gerald, what's up, buddy? Come in and hang out with us.
Hey.
Oh,
year of the hole.
That's right. Oh,
you got to make a T-shirt. Year of the hole.
Be the hole. You are the hole.
That's so bad. Ben's like the perfect voiceover guy, isn't he?
Yeah, really. Yeah.
It'd be like every commercial with us.
Yeah.
3 holes.
3 holes.
Oh,
I am Canadian.
he's Canadian. 3 holes. Oh man, Gerald, we miss you, buddy. Oh,
all that great content when we did my show there on Saturday.
Oh, dude, the the whole space station becoming a gas station for people. It's a 7-Eleven gas station. Absolutely hilarious, Mike. That was awesome.
That was funny.
Be one with the whole. That's right.
A 3-hole
Oh,
garage.
Jeff finally got his computer running. Nice.
Yeah, he seems to be plagued with bad computers.
Yeah, I wish you would have just told me or something, man. I would have sent him one.
You know what it is? He's got his computer too close to his experiments, and no, it's true. I was just thinking about that. You know, I hope he keeps his laptop or his computer upstairs, because like some of the stuff he's doing, if he's throwing a field that's like 10, 14 feet in diameter, any sensitive electronic, it's not going to be a good ending, right?
No, Mike. Let me tell you this right now. My whole garage. I have my computer in here, right? It's probably about 8 feet away from my work area.
Mm.
So when I put on my gravity flyer or something, it starts going doo-doo-doo, doo-doo-doo. It'll bring up its own pages and stuff.
Oh,
So
really?
It absolutely hates that machine. So that machine mostly, unless I'm testing to start it or something just to check it, it's outside now. It won't. It's not allowed back in the garage.
Yeah, no. That's probably what was happening with that guy's trailer up in Anchorage. He was creating such a field that, you know, he didn't need to use the mouse. It was moving on its own.
Oh man, that'd be so cool. Yeah, we were talking about that shipping container that
Yeah.
they did that experiment in. That's wild.
Yep. Yeah, the big thing is got to be insulated from the ground. It cannot be grounded. Rubber tires are on blocks. So
I wondered about that.
because the actual ground itself is actually the container.
Yeah, it's
Yeah.
a floating ground.
Yeah.
Yeah. So that makes even more sense in like when Joel showed the floating ground when he was doing coils. He did a short coil, a longer coil, and then he said he put as many coils as he wanted around it, and it'll pick it up. But
Yep.
the ground had to be the same size as the original coil.
Right.
And then it acted as a floating coil, which was, a floating ground, which was totally awesome.
Yep. 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 It's Gerald's.
Yeah, Gerald says control the mouse with your mind. Gerald, that would be the most coolest experiment in the world because I would replicate it all day. I would literally wind wires until my hands bled to get to that.
Yeah.
So, oh, that'd be so cool, man. Yeah, man, we got a lot of stuff. Everybody's in the chat. Oh, look at that. We got some Gerald and some mushrooms in there. Some Joe and some jokers. You see that, Mike, that they put those emojis on there?
Yeah, I've seen it.
That's so cool, man. Oh, yeah. So that thing I built is like I said, it's like an energy well. It doesn't matter what the heck I put into it. Like within reason, obviously. I couldn't get the PLA to light up, but if it was metal,
It's a
glass,
PLA is a dielectric.
yeah.
Yeah.
So I got metal, I got glass. I put metal wire in there, baling wire or stuff like that. All that stuff works. Any kind of aluminum works in there. I thought with the eddy currents it might do something different. No, it worked great. I hooked it to that steel plate. Still worked. It took a little more effort because there's a lot more capacitance. Probably took a while to charge it up, but it still goes in there. So it's pretty interesting. I kind of want to take the fields, and since I have a north and a south of my Tesla core, or top or bottom, however you want to say it, I usually connect the wire only to one side. So I want to connect one to each side and see if I can pull a field between it, if I can get a dielectric going.
Yeah. Interesting to see.
Yeah. Yeah, that'd be cool. The VIA model with this energy. That'd be awesome. Yeah. So cool, man. Yeah, let's check this out. Mike, I got another video. I've been in the garage working like all week on this stuff. So I wanted to show you this. Let's see. I wanted to show everybody this test. This is basically just a DC flyback. And as you can see, I have it wound on one side. This is normal for a flyback. Here's the wire. It's connected to the bottom of my Tesla coil to the rod coming down it. Now, the question is it a pulse that turns them on? Or is it AC and DC? Well, it's just interesting that it lights up. It's not a great amount, but it still works. It's funny because this energy just goes through everything like a pulse wave in it, and it's more of an energy transfer, and it just transferring the energy to that DC flyback, and it works. I never thought it would, but I had to try it. Volunteer for testing.
Yeah.
Well, it'd be an all-day thing, man. I generally test all day for like a day straight, and then take a day off. But yeah, I pretty much think we have what would be classified as an ether here, and if not, it's really close. So I let Gerald be the judge of that one. You've been watching my stuff. There's some safety stuff we need to bring up on the live on Wednesday. Different materials break down differently, ways that we do not see. Well, that would be important. Oh, man. That should wave through matter. Okay. Email in my box. Okay. Yep. All right. So I think what basically is happening is as we get closer and closer to this, to putting more energy in it, we're going to have to figure out what's going on. So I think Gerald's right. We're going to have to really look at the different materials going in. But like I said earlier, man, we can put a lot of stuff in here. So I did do one test, and I'll tell you this right now. I connected my number 2 coil, and I wanted to see if it would do the same thing as my one wire energy. And I would suggest no one ever does that test again. Never hook your number 2 coil to anything that I'm doing here for this. I had the most gigantic headache ever. I wanted to vomit. There was nothing good about it. It was completely destructive. And never do it again, ever. And don't get me wrong, it can produce some good results and stuff like that, but it's 100% not worth it, and it's a wrong way to go, especially when I show everything. So another thing, guys, is we also looked at, and I'll bring it up here, because I had some people question me on this, so I'd like to answer those questions when I can. Let's see if I can find it here. We have the hairpin circuit. So give me a second to pull it up. So I'll just pause it so we can talk about it. So we looked at the hairpin circuit, right? And here's basically what it is. Now there's 2 things missing here, and I'll tell you what they are. Right after the Tesla coil, but before you get to those air capacitors that I'm telling you about, there's a spark gap that goes in between them. And on the other side, it's just your circuit to connect it. So whether you're running in a smart guide Tesla coil or like I'm doing, whatever that is what that is. Now, when I put that rod down the center, I just want you to understand this. The only thing I'm doing is taking the magnetic field of the outside of that coil and putting an air gap between that and the rod on the inside, and I'm getting the highest Tesla level I can. So it's giving me cold energy. Tesla also had cold energy, and he did it with the one rod down the center after he figured it out. This is the version before he did. You can see the air capacitor right there. Sean showed them on one of the last lives on a Wednesday. You put the capacitors like this. You can move them up and down and change the capacitance in it. But pretty much it's breaking the circuit. Once you break that circuit with this energy, as long as it doesn't spark over, again, this is a field circuit, so it's not intended to spark. If you have sparks, stop, spray some coating over it, and then wait for it to dry and do it again. The only other thing missing from this, guys, because it's working the exact same way, is at the very bottom on the right-hand side, they had two little paddles attached to it for other things that he used it for. So when I tell you I hit the right track with the one rod down the center, it's exactly the same. Now, you can look up his patent and see what that is. We're not allowed to talk about it on YouTube, but that's exactly what's going on. Let's see, some clarification on that one, Nathan. Like that is, yeah, we'll see it on Wednesday, Gerald. But look, it's pretty much the same thing. So what do most people show when they show this circuit? Let's just get to that. They show that you can run this thing in water. And you saw in my experiments earlier, I could put the light in the water, no problem. And I can put my hands in the water with it, no problem whatsoever. So it's doing the same exact stuff, lighting up light bulbs and things like that. Do I think one's better than the other? I don't know. But could I run it like this? Absolutely. Can I get the same energy? Yes, I could. I do it a little bit differently, but it's almost the same thing. So, okay. Let's see. Was the one-wire energy into the secondary? And if you're talking about the Tesla coil with the with the tinfoil around it, then no, it wasn't into the secondary. It was only into the primary, and it transfers wirelessly to the secondary, down the voltage to the primary. Yeah, we'll have to talk a little bit more, Ian, and see exactly where you're going on it, because I know you're working on the transfer end of it to get it back to regular voltage. There's another way to do it. So I showed one way, by the way, where you get it back to the hot energy, but there's a voltage caps and stuff like that you could do that Mike was talking about. Gerald also talks about it, and you were doing it as well, but I think we can amplify that. So yeah, well, I'm happy it's going well too, Gerald. I'm looking forward to seeing you, man. It just sucks that your computer's been down for so long. I might have to build you like a bulletproof computer. Oh. Right on. So let's we'll stop sharing that one. Let's see what else I did today. Man, I got through a lot of stuff. So in my many adventures here, I ran my rodent coil as a Tesla coil. So I'll let you guys see that one. I wanted to see if I couldn't excite my rodent coil by just putting a little coil in there and putting a pulse in there. So you see the wires connected to the light bulb that's right there. Just to one of the channels on my rodent coil. I have this little coil in here. It's not connected to anything else. It's just in there. Connected to the wire. It goes to the center of my Tesla coil of the rod. So it's just putting out a pulse. So now I'm just going to turn it on and see if the light turns on. And there it is. The light comes on. So what do we learn from this? Well, it's a simple pulsed magnetic field that gets into the windings of this other coil. It doesn't matter if it's in the center or on the outside. Not really. It all still works like a Tesla coil. It's creating one pulse that goes into the next thing. It's about as simple as it gets. That's so interesting. And it just lights up pretty nice. Turn off the light and play with some more bulbs and see what it does. So yeah, it lights up pretty bright. Not bad at all. Yeah, it lights up right over top of it. Yeah. That's funny. Yeah, goes way up there. That's pretty good. I find it absolutely hilarious. So you can always tell me if I put the light over the top of it, hey, it's just lighting up based on the coil you hooked it to because it's hooked to your Tesla coil. Well, this is an open circuit. The rod's not attached to anything in my Tesla coil. It simply runs down the center of it. Not an attachment to it. My number 2 is not attached to it. My number 1's not attached to it. It just runs down there. So you can see we're getting it here. And we get it there. That's just so cool, man, that I can keep doing this. I guess it doesn't matter which coil we do it to. It still does it. It's just inducing a field into another coil and then making that coil have a field around it. It's a pretty simple understanding, but it's simply just pulse DC. That's all it is. You could say it's AC or whatever. I don't know. To be honest with you, I put DC in the beginning of it, and it runs everything. So you tell me. All I can tell you is it works. Anyway, pretty cool test, man. So as you guys can see, pretty much however I want to hook this thing up, and it doesn't matter if it's a pancake coil, it's a rodent coil, AHA coil. Guys, it doesn't matter. This energy runs everything. It goes in water, it goes in sand, it goes outside, it goes in buckets. I mean, it literally is the one and all one wire power. And you know, I don't know how much testing I need to do to get it to be ether and everybody be satisfied with that, but it's fairly close. And I think once we're able to control the hot and the cold, we're going to be able to do a lot more with this. So it may require like primary Tesla coil to be wound different so I can get a very, very high amount of Tesla in that center. And maybe then we'll be able to get it just right. But yeah, it's working great, man. This thing is totally awesome. So, Ben, you there?
I am here. I'm in the lab doing one more test. Couldn't get any kind of result with the IRF 540. Although when I tested it, I did not have the 100K ohm resistor attached. So
Okay.
that quick test real quick just to see. But the test I got before was drawing a lot more current, but not kind of exciting the coil to produce more voltage.
Okay.
So I'll do that. It'll probably take like 5-10 minutes. and I'll run that real quick, and I'll be right back.
Okay, let me know when you're ready.
Awesome.
So real quick, self-running, first step, absolutely. I give you that. That's why I was working with the Don Smith stuff. And it has to do with the transfer of energy and exactly what's the most efficient way to do it. And that's pretty much it. I mean, look, when Ian started putting 6 rods down that Tesla coil and he started getting energy from each one of them, but it didn't affect the primary, it kind of tells you we don't have a problem getting to that. So Mike told us how to combine energy, how to combine amps and volts together. Again, don't think we're going to have a problem. It has to do with the configuration of parts. That's it. We know it's possible. We know kind of which parts we have. We're going to have to test each one to see if they go through it and do it. Once they do, and we hit that, it's a game changer at that point. You're absolutely right. So, okay, so what do we got here? Gerald talking about dream catchers. Yes, they show the field of energy. They some things in what they're doing show certain fields, and then some things show you how things work. Sometimes they're flow of energy. So one thing I did share on my channel, by the way, is we did a live a while back, and we had a bunch of pictures that were on there about crystals and stuff. They are on my site right now, so you can check that out if you wanted any of those pictures, if you wanted to download them or anything. And I added a whole ton of other pictures in there as well. So just throw on the best music in the background and watch it. It's about 30 minutes long, but there's a whole lot of information in there. So, yeah. Give you guys all something cool, man. Joe, for you, buddy, because you missed something, I'm going to play it just so you can have a little fun here. Got to always have a little fun, guys, when we do this. Give me 1 second.
Yeah, you did. Oh. Whoa, 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 whoa. Oh my god. That's too good. I want to do the dance now. Whoa, whoa,
Oh, man. Yeah, we were doing a live show about the drones in New Jersey, and I had to have some kind of alien thing on there. So just to have some fun, I built it. Dude, it's just funny.
I want to watch it again. Play again. Play it again. Play it again.
Oh, man.
Play it one more time.
I'll play it for you one more time.
Oh my god. There we go.
It's hilarious, man.
He's been dancing in the street too. That was the best. Oh wow. That's so funny.
Oh man.
What did you title that video?
Oh, I think it just said Jones Bay, New Jersey. And it said, yeah, we needed lunch.
Oh my god, that's perfect. That's great. I love it. I love it.
All
That's
right,
so funny.
we'll get back to some more serious stuff, Ben. Let me know when you're ready. I'll play another video
Yeah.
real quick.
Yeah, 5 more minutes. I'll be back.
5 more? Okay. So, let's see. We'll go with this one, guys. I don't know if everybody saw this one. Probably not. And sorry, guys. I like to play and have fun as much as I like to work. So I'm having fun with my Tesla coil. I just set it up here for you. Tesla coil, rod down the center, hooks in the bottom, just like my other videos. It's run over here to my bipolar Tesla coil. One wire connects right there. Makes this other coil, my number 2 coil, on this one hot. So let's find out what we can do here. Now, is it truly hot? Is it truly cold? I don't really know. Let's just turn it on, find out. So we're on right now. We're resonating. And we're just going to check it with our light and just. We're lit up, but that's pretty poor. Well, I shouldn't say that. It's lit up. It's poor because that wire is connected. As you can see right there, it's connected all that mass. So we have no light up yet. We are at 10 volts. Oh, now we're getting some good light up. Okay. Take it away. We'll see if it lights here. So far, nothing. Oh, there we go. Now it's on. Might be all the crinkliness of everything that is causing a problem. Now I have some water over here. Guys, if you haven't noticed by now on my channel, I like to have fun and I like to test things. So why not just have fun testing things? This is something we'll have fun with. Okay, so I just connected one to there, one to there. That's it. Pretty simple. All I want to know is if it'll light up now. So let me get you a better shot. Put it in the water, it lights up. See if I can't do better on the shot. Here we go. It turns off. It's off. Dip it in the water, turns back on. Oh, this is like a fun game. Okay, let's try it again. Well, it's back on. And we'll go to the last one, and we're there. So is that glass an insulator? Oh, no. Not as much as you think it might be. Let's turn back off, turn back on, turn back off, turn back on. Yeah, okay. We're having a little fun. Now let's just connect it to the rest of the stuff here. Oh, there we go. So we got a good connection there. It's on. And by the way, it's still on right here as I just wiggle this wire over now. I'll turn off the light so you can see it. So get those lights off and get this thing running. Okay, lights are off. Thing does not like the crinkliness of this. See if it likes the edges. It does with my hands next to it. Okay. Might tell us something about it. How far up can I get it? Still lit. Hold on. Let me move that backlight. Now it's going out. It likes my hand. So that's interesting. Let's go back to the other side. Let's get that little wire now. Let's dip it in there. Sorry, it's a black wire. There we go. You can see it when it dips in. Now you can see the wire. Now, that solution has salt in it for people out there that wanted me to put salt in it. That one does. This one has no salt in it. It's got quartz. It's just as bright. This one here is water. Yeah, and this one on the end had some sand in it at one time. It all lights up. Okay. Well, that's cool. Still lit. Okay, now it's out. Ooh, look at that. Now it's brighter on that. You know, I'm just having fun with Tesla coils, guys, and I'm trying to see what they do. So just understand that. Lights up nice and bright over here. Lights up less on this. All right, so we can see that we could do a bipolar Tesla coil, start lighting stuff up. So let me see if I have a different one on here. I think I was looking for something else. Might have been this one. This experiment's going to be a little different. It's probably going to be in two parts. Right now, I have my whole table covered in tin foil. Just a little kitchen tin foil. I have my Tesla coil, my rods down the center. That wire right there, that green wire right here, connected to my rodent coil. My rodent coil is connected to the foil on my table. Now, I guess the expectation for this is that the whole thing's going to light up, right? So let's go ahead and turn it on. We're resonating right now. My light bulb's not on. So what's going on here? This should be lit up like a Christmas tree right now. It's on when I touch it. Touch the foil, nothing happens. I touch the light, it goes on. So, let's do something fun here. There's my gravity flyer. I'm going to use it as grounding. Just a big mass of metal is all I want you to understand about it. We're going to connect it right here to the end. We're going to see if we can change the dynamic. Now my gravity flyer is not connected into anything. It's simply a grounding source. Lights back on. It's on where it's grounded, by the way. You notice the right side's not on. Now I can touch it. So let's do this. Let's turn off the light so we can get a better look. And then we'll continue with the test. So let's look at this side. Let's focus over here. That side's lit up just fine because it's grounded again to the gravity flyer. I touch it. It goes up slowly. Now I'm also a grounding source. I'm also capacitance. And again, we can touch this and the light goes down because I'm completing a ground and bypassing. It's interesting. Now, I have a feeling if I connected this to my number 2 coil and adjusted for the resonance, this whole table will light up. So I'm going to do that experiment as well. But while we're here, and by the way, I'm wearing my pajama pants, and I probably shouldn't tell you that, but they're kind of staticky right now. So it's not a major effect, but I can definitely feel it coming off of this thing. So, but this isn't like normal high voltage. This is from the center of my Tesla coil. So we're getting a little bit of a field around it, and I could feel it. So
It's called the fluffy effect.
let's
Fluffy.
play with this a bit
The
more,
fluffy
and we can try to ground out the other side
Yeah, with
to
pajamas.
the aluminum foil here.
Not boxers like Ben.
I have that wire connected, and I got nothing. When I touch it, it's there. Got nothing there. Okay. Pretty interesting. Now I connected that to the water in the jar. It's not doing anything. It's not acting like cold electricity now.
That's all the
I
PJs,
think
by the
it's
way.
like the amount of mass is changing the electricity in this. So we'll have to play with it some more and see exactly what it's doing. But I'm not getting the same reactions at all that I normally would with cold electricity. So let's detach it. I got nothing on that light. But I touch it, now I do. I mean, I don't know what you want to make out of it. I don't know what to make of it yet. Is it over the table? Yeah, it is. It lights up over the table. Interesting. Oh, there it goes. It lights up now with a straight connection. Okay. That's fairly interesting. Let's see. Let's give it a little bit of distance. It's not lit up now. We're still resonating. I just set it over top. I want to see if I can't let it go. It's probably right off.
So hold on, we'll just read Ian's comment real quick. So the one wire energy field requires differential pressure, ground, or temperature to move and do the work. Yes. There's a lot of information you'll need to know on the grounding aspect of this. It's one wire energy, but just think about it. It creates a field, but then in order to get that field to go to another area or to get through more mass, so the longer the winding of it, you're going to have to pull it through. It's not able to pull through as much because you're not pushing it. So if I say hot energy, it's regular positive energy pushing through the circuit. When I say cold energy, it's there, but you need to pull it through the circuit. So grounding is going to become very important.
Oh, there we go. Now we are getting some light at a distance, not a lot. You can see there's a big spot in the center where there's no light. Now if I touch it, it's reacting. This is acting like the hot end of a Tesla coil. As you can see, it clearly lights up brighter because it likes me. And there it goes. It's still turning it on. I don't know if it's the glass or not. I come close to it. I don't even have to touch it. It's lighting up brighter. And it's doing that. Put it down, it goes less. I don't know what to make of it yet, but this is our test. So I'm going to stop and reset for hot electricity and see the difference. Okay, so I'm reading something in the chat here. Object reduces by 6 grams. So one thing I'll warn you, if you're putting something on the scale, please understand there's different effects that could go on. It could lose weight and still not be anti-gravity. So that's why I don't do a lot of tests with any scales. So I could create pressure on a plate with no problem inside of a dielectric with paper and aluminum foil and get the thing to reduce weight. But it's still not anti-gravity. You can get it to a 0 point and it's still not anti-gravity. It is simply pressure down on the plate. And you have to watch for that. So I haven't seen his experiment. Maybe he's got something different, but yeah, just watch out because some of it's not what you think it is. Let's see. Yes, ground. You have to pull it through. So my next couple tests will be capacitors and stuff like that where I pull it through. I didn't get to it today, but it's on my list. I have the capacitors built all together, and I'm getting ready to use that. And I just got to put a draw on the end of it or a load and see what we do. I don't know that anti-gravity is weight reduction. It's fields and how it interacts with the air around it. So let me just tell you this. I've been doing a lot of water tests, and I'm putting energy into the water. So when I do that, am I changing the magnetic field of the water? And that's what concerns me. Am I doing something to change the magnetics to the water? So is it pulling the energy, holding the energy? What is it doing? We can see that the glass has capacitance to it, but it doesn't activate unless you have the water. So my question is oxygen the link between air and between something else? Is oxygen the link? It's kind of a curious question when you think about it. If it is, it makes sense why this energy was used in other devices, and they said it has some kind of a gravitational effect. Well, if this is filling in your field and we're able to control the air in that field, that'd make all the sense in the world. So, yeah, it's kind of an odd comparison, but in the water, remember, it's hydrogen and oxygen, and then you get oxygen in the air, and then it blows out other material. And I can't tell you what that is, but it might just be other gases. So, okay, hydrogen is the link. Yeah, if I wanted a hot air balloon, I don't know how you get hydrogen in it to fill up inside the fields. So, I thought he was learning towards air capacitors. Yeah, well, kind of has a correlation, doesn't it? There's got to be something going on in that air with it. Yeah. Well, look, see, the thing is I know a lot of people think you need a lot of stuff for this. Let me just tell you, I don't need electrics. I don't need to change the water. It could be tap water. I'm telling you right now, the energy is different. It goes through all of it. So when you have a normal stuff and somebody's running hot energy, they're not doing the same test I'm doing. Just understand that up front. 100% not the same test. It's different energy. They're running hot energy. I can get things to run on hot energy the same way they do, Electra, stuff like that. All that's great. But as you saw, when I started dipping this wire into different things, different solutions, it didn't make a difference. It really didn't. So the only thing that makes a difference is the distance that it goes. You have to have quartz in there in order to pull the distance on the field. And that's going to be something that everybody will have to understand. It's going to require some quartz in it, or a crystalline form, because we're going to resonate the crystal to do it. That's why I tell people when we did the crystal episode, look at the geometry structure of a crystal. Look how it's built. Look that there's oxygen in there. Again, another comparison of why this is all working. I think that oxygen is the key. And once we learn how to manipulate it the right way, we'll be all right. So, yeah, this energy is so much different. It literally acts like an energy well. That's the best way I could say it. A usable energy well. Okay, Ben, are you about ready?
Yeah, so not a lot happened. We didn't get any really interesting results other than the fact that the IRF 540 MOSFET did seem to draw a lot more current, but it didn't excite the neon lamp. Neither did it actually light the 40-watt panel at all at any voltage input that I gave it.
Okay.
And yeah, and I was afraid of pushing it too high just because the current was so high compared to the I would put it up to 12 volts and it was already at 2.5 amps consumption. So I was afraid to push it more because I think that MOSFET is only rated for 5 amps, if I'm not mistaken. So I didn't want to push. Yeah, I didn't want to push it too much. I have extras, but I think the takeaway here is because it did get very hot. Obviously, it's drawing more current. It might be good for induction heating in some capacity for off the grid purposes. We'll have to do more testing and look into that.
Okay. So you had more amps than you expected to have? Is that what you said?
Well, we expected that there was going to be more amperage available on the output. And that's probably true if we measure it on the output, which I didn't. But there's just not enough voltage to do anything with it with the lighting. So yeah, the MOSFET, it's doing what it's supposed to be doing. Apparently, that's what we intended it to do, which is up the current. But at the cost of the voltage, we really can't do anything or can't see anything significant with it, other than the fact that it's heating up and is drawing more current, which could be indications that it could be stepping up the current instead of stepping up the voltage, like we see. And that could be very good for induction heating in some capacity, I can imagine. I have to test it more, and I'm kind of half asleep at the moment. To be honest, I'm a little drowsy.
Well, stop playing with it because you'll just blow stuff up at that point.
Yes, sir. Yes, I agree. So, yeah, it's interesting. We had some interesting details come from it, but nothing for lighting, unfortunately. But we still have to test with it further. I have a whole bunch of them we can, run some more tests with. Maybe another circuit or something.
Yeah. Jarvis says, try the commercial boost converter. Ben, didn't you have a converter already?
Inverter? I have an inverter.
You have an inverter. Okay.
Yeah, not a boost converter. That's something I haven't tried yet. I know people have recommended boost converters to me. But yeah, we can go down that alley.
Yeah, I think they're very cheap, aren't they? Like $10 on Amazon or something.
Yeah. Most of the components we work with are relatively cheap. $7 here, $10 there. Except for the meters and the power supply stuff that gets expensive. And the coil wire. The coil wire can get expensive as well.
Oh yeah, that's probably one of the most expensive things. Yeah, and all the coils that I build, Ben, that's the kicker right there.
Yeah,
I hate buying like a pound or something of wire and just doing like one experiment. So I like to buy 5 pounds at a time. So $100 to $200 in that range, and then
Right.
yeah, that what was it, 20 gauge? I think it was. I ran on my Joker coil. I think I paid like
Yeah, it was a little bit
$130.
It was a little bit thicker than the one that I have. I'm running 23 AWG, but you just get a little bit more current out of it, I imagine.
Well, I could handle the stress of what I put this thing through.
Yeah, with a Tesla coil. Yeah, because I don't think, mine might be on the verge of not being able to handle something like that. With a 23 gauge, I'm not, too confident in hooking my coil up to a Tesla coil.
Right on. Yeah.
Blow it out.
Dude, I put hot voltage through it, and my Tesla coil absolutely hated it. I hooked it direct.
It's mostly voltage, or is it any current at all?
Yeah, it's a little bit of current, but mostly voltage.
It's mostly
And
voltage.
it just threw me so far out of resonance, hooking it just right to my number 2 coil. It wasn't worth it. Yeah, I think I have to run the Slayer exciter to get it to work with it. And I didn't have it ready at the time. I just had my ZVS because it goes so far out of resonance. I need something that's self-correcting, like the Slayer exciter is, in order to get it.
Right.
So
yeah, no, like something that's self-correcting or self-oscillating, like simple, like the Joe Thief is self-oscillating, and it's just it works, like you don't really have to mess with it too much. You know what I mean?
Yeah. Oh, by the way, Society of High Sciences, if you got something cool, man, by all means, send me an email. It's attached to my YouTube account, and let me know what you got going on, what with the breakthrough, and then we'll see if we can't have you on and show it.
Oh, Society's got something he wants to present. That's awesome.
Yeah. Everybody likes when everybody shares, man. So you got it. Bring it. I'd love to see it.
Hey, you know what I say? Sharing is caring. And that's what you gotta go into it with. Sharing is caring, folks.
Sounds like a Care Bear.
Oh yeah. I'm a big fat Care Bear because I care about you.
Let's see. It turns out his philosophy of the foundations of technology and the advance, it can push materials to the next level. Nice. That would be cool.
Yeah. And Vor said most OU systems start with a boost conversion of some sort.
Really? I didn't know that.
I didn't either. So we're going to have to take note of that. Vors has some very insightful
Jarvis
comments. Yeah.
I know it says Vor on there. It's Jarvis.
Oh, that's Jarvis? Oh, I did not know. No wonder. That makes sense. Okay. Well, it's coming together, folks, for me at least.
Like a choke. Hey, you ever looked into that, Ben?
Like
instead of running, how do I say it? Instead of running the MOSFET the way you're doing it, run a choke.
What does that mean?
It's basically a little magnetic donut or a ferrite donut, I should say. And it's got
like an inductor?
Yeah. That's all it is. It's a little inductor choke. Yeah, it's the same thing. It'll bring heat to it, so it'll bring more amps and it'll convert some voltage to amps.
Oh. Yeah. Yeah, that could work. Just one wire, right? Just one wire around a ferrite core.
Yeah, one wire through the whole thing, yeah. You can just take it off some ZVS board you blew up and try it. You don't have a bunch of those. I do. But yeah, they're pretty cheap, man.
Bingo bango.
That's right. Captain! Yeah, that's what you need. Just try one of those. I mean, look, worst thing you could do is fail. Just don't have the power up all the way and see what it does.
Yeah. Well, I actually I do have a new coil frame that I'm about to give to my lab partner. He's going to have his lab up soon, and we're going to have somebody helping me test the coils, which is going to be pretty cool. And I also have a new shade of transparent green coming for your guys' versions of the Lightning Thief. So that's going to be neat. Yeah.
Nice.
What I'm going to do is I'm going to get the screw terminals. So it'll have like it'll just be very simple. It'll have a potentiometer at the top. And then it'll have 4 screw terminal, like a 4-block screw terminal. And it's very simple. Just that's it.
Very nice. Real quick, Society of High Science, it says that he doesn't want to share that particular thing he's working on. He might be able to teach versor vector math that allows for complex system unification. That would be awesome.
Yeah.
I would love to hear that as well. So, yeah, if you want to come on and do that, that'd be really cool. So, says he continued Eric Dollar's work on polyphase systems and developed a more advanced math with it. Oh, definitely cool. Yeah, let's hook up and then we'll get you on to share, man. Be really awesome.
Yeah, see what you got. That's exciting. Eric Dollard has some really awesome videos that I checked out not that long ago, and I hadn't heard of him before. So,
yeah, hold on. You're doing all this stuff with us and you haven't heard of Dollard?
this is going back maybe 2-3 months ago. Yeah, I hadn't heard of Eric Dollard before that.
You guys like a super legend and all this stuff.
Yeah. Well, I mean, to be fair, I learned a lot in a short amount of time. There was a lot of information that came at me from you guys, so it all like just got crammed in there, and
Crammed it in your cram hole.
yeah, the new hole. We got more holes than we can count.
Yeah, I guess it is a lot of information when you come into all this right away, when you're just trying to learn your own system.
But I was already familiar with like Tom Bearden and slightly familiar with John Bedini. I had heard his name mentioned in certain circles and read him in the book the good book, The Practical Guide to Free Energy Devices. Yeah, so I mean, there's, like I'm not unfamiliar with some of the people, but Eric Dollard was new to me. Yeah, I have to admit. But when I watched some of his videos, he was describing the transverse waves, and he was the one who actually, kind of put it into a visual, like with the jump rope. The jump rope analogy was brilliant. And he's like, okay, this is a difference between longitudinal waves and transverse waves. Longitudinal waves, transverse waves, you shake the rope and the wave goes from one end to the other, right? And you count how long it takes. Well, then you compare that to how long it takes, like say a longitudinal wave, which is basically just pulling the rope from one end to the other, and it's instantaneous, So
yeah,
it's a brilliant analogy. I'm not sure it completely encapsulates the phenomenon, but it's able to get your mind around how it's possible. You know what I mean?
Yeah. Well, that's kind of sorry, my camera's off. Sorry. Yeah, it's kind of why I was surprised, because he has a ton of stuff. Yeah, and there's some other guys out there. Linderman, you ever watch him?
I have not. Linderman.
I believe that's his name. They'll correct me if I'm wrong. God, there was another guy who does physics, an old guy, and I forget his name right off the hand, but he's like brilliant at it, and he shows you where resonance is and anything. Matter of fact,
Peter Linderman, Mike said.
Yeah. Okay.
Huh.
I want to see if I can't pull up that one guy. Here, no, that's not him.
Yes, yeah, I was going off of, like, if you can think of my origin branch of like investigation, I started off with investigating Daniel Nunez of One Stop Energies, and then what he was looking up, and the people he was watching and stuff like that, and it branched out from there. That's kind of like the root, though. That's how I got into all this, basically.
Yeah. That makes all the sense in the world, Ben.
Yeah. And there's a lot of videos, honestly, that we're just discovering that are still out there of Daniel, and him talking about his research that, I'm still going through some of it. It's, it's out there. It's just hard to find.
Gotcha. Sorry, I'm trying to look something up, Ben, and I hate it when I can't find something.
I'll read some comments. Charles
go for it.
Milligan says longitudinal are represented well by that device with a row of steel balls on strings. Pulling rope works as a description too. Dr. Peter Linderman does a Tesla talk that is worth watching. Are you talking about the row of balls on a string? Are you talking about the Newton's cradle? I think he's talking about a Newton's cradle.
Ooh.
Maybe. I don't know, unless there's something else that I'm missing. That's the only device that I know that has a row of balls on strings. You pull one back and it demonstrates, the transverse of energy.
Oh man, you know what? I got the name now and I can't spell it right. That go figure.
Man, I can never spell anything right.
Julius Sumner.
Sumner with an M?
Yeah.
Sumner.
Here we go. I'll just show you the picture of it real quick so everybody knows what I'm talking about.
Yeah, Charles, I think you're referring to a Newton's cradle. That's the desktop toy. Yeah, you pull one end and then it goes back and forth. Yep.
So this right here is Julius Sumner. I'll go ahead and drop this in the. Oh, where is it? It's right there.
He's got some tuning forks in the back. And he's also got some of those flasks.
Yeah, this guy finds resonance in everything. So what it is, he shows you the resonance between two boxes, right? And I don't want to play it because I don't want YouTube yelling at me, but he shows you that.
This guy,
Yeah.
I've seen a clip of this guy before. Maybe not the entire video. Yes, I've seen this clip before from this video, though. This is amazing.
Yeah, he finds the resonance in the tubes. He finds it in the glass tubes. This guy is way cool, man. If you want to learn about resonance and how to find it, he tells you about the guitar strings. Trying to see if he has the other string in here. But I left it in the description in case you wanted to watch it. But this guy is absolutely amazing when it comes to resonance. So, yeah, if you ever wanted to watch something like that, watch this guy.
I mean, it looks intense. Look, he looks like he knows his crap.
Oh.
Look at that face.
That guy would school you inside of a minute if you walked into his classroom and talked gibberish.
Yeah, no, I would not doubt that for a second.
Oh man. Yeah, old school, that's right.
Yeah.
Well, I'm gonna tell you this, there's not a whole lot of physicists out there that teach resonance like this guy does.
Mm-hmm.
Yeah, I don't want to get in trouble with the copyright issue. I just wanted to show people who I was talking about.
It says lesson 34. So are there potentially like a lot of those videos from him?
Not of resonance. I think he's got 3 or 4 resonance videos, but he's got a lot of physics videos. And he does a cool one with pressure in this big jug thing that he has out there, like a 5-gallon drum.
Mm-hmm.
And he's showing you pressure differential and stuff like that. So he's definitely one to watch, man. If you just want to just get a basics on physics, watch every one of his episodes. It'll help you out big time.
Oh, neat.
Yeah, hands on. That's right. So I like that guy a lot, man. I don't know if he's still around or not. I doubt it, but it would have been a fun conversation to have with him based on what I'm doing, and then you know what he would do. So yeah,
Better than the people we have now, like Neil deGrasse Tyson and Bill Nye.
oh god, I don't know about Bill Nye. I don't watch him. The Tyson guy, not a chance. That guy is a misinformation machine, and I will not watch. So
They're both clowns. They're both clowns.
yeah, maybe I don't know about the other guy. I've never seen the stuff. I don't know, man. When they start to get political, I'm out, and yeah, I just want straight information on stuff.
Yeah.
So,
No, I agree, and that is a problem. They mix it, and it's it's like get back to the science.
yeah. Anyway, all right, Ben. Man, it's been a great show tonight, guys. Like I said, there's a lot of stuff on my membership page. If you guys want to check it out, I do all kinds of tests all the time. I always put them on there. I always give everybody first looks, and there's some stuff that just stays on there. So anyway, with that said, we got a Wednesday show coming up. Gerald will be back, and we're all going to rock it out on that day. Sean will be there. We're going to have an awesome, awesome looking show. Ben, what do you got going on? Anything?
Well, in the meantime, honestly, the only thing I'm going to be doing is practicing that new dance. Wow, wow, wow.
Yeah, I think it's so cool, man. I had to do it.
Oh,
I had to do it.
But yeah, no, I'll mess around with the coil a little bit and give you guys some updates.
Yeah, try one of those chokes if you got it. That'd probably work good for you. You probably have one in that what is it? That amplifier you blew up. I bet you there's one in there.
You know what? Yeah, I just have to get a couple of things from Amazon to help me desolder things from the board. That's it. So there's something that I think Sean, either Sean or I think it was Sean, he recommended. I forget. It's on my list though. It helps you get components off of boards. So I have a bunch of boards too that I can recycle like that. You know, heat sinks and all that stuff that are just stuck there like useless. And they're frustrating because I need those heat sinks. I need you, heat sink.
Yeah, right on. All right, guys. Have a great night. I want to thank everybody in the chat. It's been really awesome. We had a fun time tonight. Love laughing, love having fun, man, learning a little bit in the way.
Yes, thank you, everybody. I appreciate everybody and appreciate all the love and the support. Thank you, Nathan. This is awesome.
Have a great night, guys.